In this video, we are gonna make a great sounding bass boosted audio amplifier by using the LM386 IC. There exist many versions of the LM386 IC that have different operating voltages and output power ratings. For example, the LM386 NDS1 and NDS3 operates from 4 to 12 volts and the LM386 NDS4 operates from 5 to 18 volts. The output power of the LM386 NDS4 is roughly 1 watt. The actual output power you will get depends on your supply voltage and speaker impedance. So let's talk about its pinouts. The IC comes in dual inline package and can be powered using pin 6 and pin 4, where pin 6 is VCC and pin 4 is ground. Pin 2 is the inverting input, which is normally connected to the ground, and pin 3 is the non-inverting input, which is provided with the audio signal. The amplified audio signal can be obtained from pin 5. Pin 7 is the bypass pin. We can connect a capacitor between pin 7 and ground to remove noise distortion and unnecessary oscillation. The pin 1 and 8 are used to set the gain of the amplifier. So what is gain? The gain of the amplifier is the amount that you are multiplying the voltage by. For example, here is an amplifier that takes 1 volt at input and gives 10 volt at output, so we say this amplifier has a gain of 10. The gain or voltage gain is represented by AV is equals output voltage divided by the input voltage. Now let me explain the circuit. The pin 6 and pin 4 is connected to positive and negative of the battery to power the IC. The inverting input pin 2 is connected to ground. Pin 3 is connected to middle pin of potentiometer. The audio input signal is connected to the third pin of potentiometer, and the first pin of potentiometer is connected to ground. Here the potentiometer works as a voltage divider and is used for the volume control. Pin 5 is connected to the positive pin of a coupling capacitor, and the negative pin of the capacitor is connected to the speaker, and the other pin of the speaker is connected to the ground. Here I am using 4 ohms 10 watt speaker. And the value of this capacitor is 1000 microfarad. Why 1000 microfarad? To understand why I am using 1000 microfarad capacitor, you have to know about capacitive reactance. The opposition to the flow of alternating current due to capacitance is called capacitive reactance, and it is measured in ohms. The capacitive reactance is represented by this equation: Xc is equal to 1 by 2 pi Fc, where Xc is the capacitive reactance, F is the frequency of audio signal, and C is the capacitance. So at a frequency of 100 Hz and given a capacitance of 1000 microfarad, the reactance at this level is gonna be pretty low, 1.59 ohms, which is what we want because we want both the low frequencies and high frequencies to pass through this capacitor. As the frequency or capacitance increases, the capacitive reactance decreases. These two have inverse relationship. If we use a 100 microfarad capacitor and keeping the frequency same, the capacitive reactance increases to 15.9 ohms. And if we increase the frequency to 1 kHz and have a capacitance of 1000 microfarad, the reactance decreases to 0.159 ohms. So it's very easy for high frequency to pass through the capacitor and not so easy for low frequency to pass through. So if you want to get a sound with high bass, then you should use a high value capacitor. Otherwise, the low frequencies, they're gonna have high reactance, so they can be attenuated by the circuit. So let's build this circuit on a breadboard. I am using this row as positive rail and this as negative rail. Insert the LM386 IC on the breadboard. Connect pin 6 of the IC to positive rail. Connect the upper ground row to lower ground row. Connect pin 4 of the IC to ground. Connect pin 2 to ground. For providing audio signal from my smartphone to IC, I am using this 3.5 mm audio jack. This longer pin is ground. And this pin is the left audio output. And this is the right audio output. Insert a 10 kilo ohm potentiometer on the breadboard. Connect the middle pin of potentiometer to pin 3 of the IC. And the first pin of potentiometer to ground. Connect ground of the audio jack to negative rail. And connect any one of these two audio pins to third pin of potentiometer. Connect positive of a 100 microfarad capacitor to pin 7 of the IC and negative to ground. Connect positive of a 1000 microfarad capacitor to pin 5 of the IC and connect one pin of the speaker to negative pin of 1000 microfarad capacitor and the other pin of the speaker to ground. Now the circuit is ready. For powering the circuit, I am using two 3.7 volt lithium ion batteries in series, so it will give me 7.4 volts. Let's play music. We can control volume by turning potentiometer. As we heard that there was some noise distortion. To remove the noise, we have to connect a 1000 microfarad capacitor to the input of this circuit. This capacitor filters noise distortion caused by power supply. And a 0.1 microfarad capacitor in series with 10 ohms resistor between pin 5 and ground. This will work as a RC high pass filter that will send all the high frequency signals to ground, so it can't interfere with the audio. Connect positive of a 1000 microfarad capacitor to pin 6 of the IC, negative to pin 4 of the IC. Making the connection as short as possible will also help in noise reduction. Connect one pin of a 100 nanofarad capacitor to pin 5 of the IC and the other pin to ground via 10 ohms resistor. Let's test this circuit. Now as you can hear, all the noise distortion have removed. If I remove the capacitor, then the audio gets noisy. If I insert the capacitor again, then the noise distortion will remove. Now let's add a gain control to the circuit. If there is nothing connected between pin 1 and 8, then the default gain will be 20. And if we connect a 10 microfarad capacitor between pin 1 and 8, then we get a maximum gain of 200. Now let me explain the gain circuit. If we look into the internal schematic of the LM386 IC, then we can see there's a 1.35 kΩ resistor between pin 1 and 8. This resistor sets the gain at 20. If we somehow decrease the resistance between pin 1 and 8, then the gain of the amplifier will increase. If a capacitor is put from pin 1 to 8 bypassing the 1.35 kΩ resistor, then the gain will go up to 200. If a resistor or potentiometer is placed in series with the capacitor, then the gain can be set to any value from 20 to 200. Here I am using 10 kΩ potentiometer in series with 10 microfarad capacitor between pin 1 and 8 to control the gain. Connect negative of a 10 microfarad capacitor to pin 8 of the IC. Now insert a 10 kΩ potentiometer on the breadboard. Connect positive of 10 microfarad capacitor to third pin of potentiometer. And connect first pin of the IC to middle pin of potentiometer. Now we can control the gain by turning the potentiometer. If I remove the capacitor, then the gain drops to 20. If I will insert the capacitor again, then the gain will increase to 200. After you build this amplifier and play with the volume and gain control, then you will notice that both appear to rise or lower the intensity of the sound. So what's the difference then? Gain is the amplification of the input potential and is a characteristic of the amplifier. Volume lets you adjust the sound level within the range of amplification set by the gain. An amazing feature of the LM386 IC is the option to add an adjustable bass boost to the amplifier. The bass boost is basically just a low pass filter. So what is low pass filter? A low pass filter allows low frequencies to pass through it and blocks and attenuates high frequencies. So on the upper left we have low frequency signal, and as you can see on the output the amplitude is almost the same. And here we have high frequency signal on the bottom left, but on the output the amplitude is greatly reduced by the low pass filter. An RC low pass filter made out of a resistor and a capacitor, and this circuit looks very similar to a voltage divider circuit. The output voltage of a voltage divider circuit is Vout is equal to R2 divided by R1 plus R2 multiplied by the input voltage. If R2 increases, output voltage will also increase if we keep R1 the same. If we decrease R2, output voltage will also decrease since R2 is on numerator. And the output voltage of an RC low pass filter is Vout is equals to capacitive reactance divided by impedance multiplied by the input voltage. Impedance is just the effective resistance of an electric circuit or component to alternating current arising from the combined effects of ohmic resistance and reactance. So the impedance is root over R square plus XL minus XC whole square. Since there is not an inductor in this circuit, therefore inductive reactance is 0. Since Xc is equals 1 by 2 pi Fc, if frequency increases, capacitive reactance decreases, since F is on denominator. Therefore, output voltage decreases as well. Therefore, the low frequency signal goes towards the output and high frequency signal will be sent to ground. That's how low pass filter works. It passes low frequency signals to the output and attenuates high frequency signals. The RC low pass filter has a frequency response that looks like this. Here we have F on x-axis and dB on y-axis, and this is the shape of the graph, and this is the cutoff frequency. At the cutoff frequency, the signal drops by 3 decibels. The equation of the cutoff frequency is Fc is equal to 1 by 2 pi Rc. So as we increase resistance or capacitance, the cutoff frequency decreases. Now at the cutoff frequency, the output voltage is 70.7% of the input voltage. Now at this point we will have a decimal drop of 3 dB, and we can calculate that with this formula. The decibel is equals to 20 log multiplied by the ratio of output voltage to the input voltage. So it's 20 log 0.707, and further calculating it we will get minus 3.01, which corresponds to 3 decibel drop. So that's where that number comes from. If we have 10 kilo ohms resistor and 10 nF capacitor, then we get a cutoff frequency of 1592 Hz, almost equal to 1600 Hz. This means that the frequency below 1600 Hz, the signal passes through unchanged, and at a frequency of 1600 Hz, the amplitude reduced by 30%, and the frequency more than 1600 Hz will be attenuated by the circuit. If we place this RC low pass filter at the input of the IC, then we will get a bass boost, but we are not gonna do that because there's more easy method than this. All you need for the bass boost circuit is a 0.033 microfarad capacitor and a 10 kilo ohms resistor in series between pin 1 and 5 as mentioned in the datasheet. Now let me explain this bass boost circuit. At low frequencies, let's say at 100 Hz, the capacitive reactance is 48.228 kilo ohms, and calculating the impedance of this RC circuit, we will get 49.25 kilo ohms, and at high frequency of 1 kHz, the impedance is just 11.1 kilo ohms. If you look into the internal schematic of the LM386 IC, then you will notice that there is a 15 kilo ohm feedback resistor between pin 1 and 5. If we somehow decrease the resistance between pin 1 and 5, then the gain of the amplifier decreases as well. So this RC network of 0.033 microfarad capacitor and 10 kilo ohms resistor is in parallel with the internal 15 kilo ohm feedback resistor. So the equivalent resistance between pin 1 and 5 becomes 11.49 kilo ohms for low frequencies, and it becomes 6.38 kilo ohms for high frequencies, and thus the gain and amplitude of high frequencies reduces and only the low frequencies gets amplified. In a nutshell, at low frequencies, the external series RC network is effectively an open circuit, so the amplifier behaves as if the network isn't present, and at high frequencies, the RC network is effectively just a 10 kilo ohm resistance. Note that this 10 kilo ohm resistance is in parallel with the internal 15 kilo ohm feedback resistor. So instead of a 15 kilo ohm feedback resistor, there is at high frequencies effectively just a 6 kilo ohm resistor. That is, there is more feedback at high frequencies and thus reduced gain. Now let's do it practically. Insert a 10 kilo ohm potentiometer on the breadboard. Connect one pin of a 0.033 microfarad capacitor to pin 5 of the IC, and connect the other pin of the capacitor to middle pin of 10 kilo ohm potentiometer, and connect the first pin of the IC to third pin of potentiometer. Now we can adjust the bass.